Okay, now currently you got 2 ohm here, 8 ohm, and 2.4 ohm. Okay, what he's saying is based on the first question. This one. Okay, so to combine these 3 into one effective resistance. Okay. Now, how to do that? First, you look at the 2 parallel one. Okay, if you combine the 2 parallel into one resistance, then you have this resistor connect with this resistor. So this the combination of these 2 will end up with one resistance. So this resistance and this resistance is actually connect in series. So you just add this up. But before that, you must convert this into a single one. Okay. Now, the formula for 2 parallel resistors is basically 1 over R, 1 over R1 plus 1 over R2. Okay, so 1 over 2 plus 1 over 8, they give you 8, here's 4 plus 1. 2 times 4 becomes 8, so that's why it's 4. So R inverse it is 5 over 8, so now 8 over 5, is 1.6 ohm. Okay, in other words, okay, so these 2 resistors combined give you this. Okay, so now, so basically now you have these 2, this and this. So if you look at these 2, they are basically this will be 1.6. Okay, so total resistance, total equivalent resistance. Okay, for these 2 resistors connect in series is just basically adding up 1.6 plus 2.4. That gives you total of 4 ohm. Okay, so this is actually effectively 4 ohm. Okay, now, so the whole circuit can be just represented by so now you have 4 ohm, you have 12 volt here. Okay, the resistance. So using the formula V equals to I R, which R is the effective equivalent resistance. V is 12 volt, so it's 12. Equal to I R is 4 volt. Therefore I is equal to 12 divided by 4, which gives you 3 ampere. Okay, so this ammeter which is the total current flow at the ammeter. Okay, this is for your A part 1. So your part 2, A part 2 is actually 3 ampere. Okay, that means this ammeter will show 3 ampere of current flowing through. Okay, if you want to draw the line, then you just put I equal to 3 ampere. Okay, now let's come back to let's do the third one. The third one basically is asking you the voltage across this. Okay, now if you look at this, okay, let me use this. Since we have found the current is 3 ampere, so the current that flowing through this 2.4 ohm resistance, the current that flowing through is still, because it's the same, okay, this ampere along the path here, the current that flowing through all this single path, okay, single path of the journey, all this I is equal to 3 ampere. Okay, the only difference would be here, where the 3 ampere have to split between the 2 ohm and the 8 ohm. Okay, but that's not needed to calculate any regarding this here. So you just focus here. So at this point here, the current is still 3 ampere. At this point, the current is still at 3 ampere. So the current that flow through this 2.4 ohm resistance is 3 ampere. So to calculate the voltage is a very simple one. So voltage is equal to IR. Okay. So in this case, the current flow through the resistor is 2.4 times the resistance is, sorry, the current is 3, resistance is 2.4 ohms. You get 7.2 volt. Okay, so volt equal to I times R. Okay, that's it.